In this example, we're going to be using the properties of logs in order to solve this log equation. So the first goal on the left-hand side is to combine both of these logs since they have the same base. We're going to combine them using the quotient property because I see this right-hand side, two logs of the same base that are being subtracted. So I can rewrite it as one single log with the same base. The base is 7. And then we're going to create a fraction, and the numerator, in this example, the numerator is whatever the argument of the first log is, and the denominator will be the argument of the second log. So the argument of the first log is the 3x to the third plus x, and the argument of the second log is just x, and that's equal to 2. So I'm going to simplify the argument. We're going to divide both terms by x, so I'm taking this and dividing it by x. So 3x to the third divided by x is just 3x squared, and then x divided by x is 1. So let me rewrite that. 3x squared plus 1, and that's equal to 2. So from here we need to get rid of the log completely. So if I have log base 7, what I can do is I can exponentiate both sides by using the exact same base as the log here. So I'm using base 7 on the left side and base 7 on the right side. What that does is that cancels out the log because those are inverses of each other. So all you're left with is the 3x squared plus 1 on the left side, and 7 to the second power is 49. So I need to continue to solve this. So I'm going to subtract 49 from both sides. So I get 3x squared minus 48 is equal to 0. And so from here, I'm going to factor and apply the zero product property. So I could factor out a 3, and what's left inside is an x squared minus 16. And then I can factor the x squared minus 16 as the difference of squares. So alternate your signs, one's a plus, one's a minus. X squared splits as x times x, and 16 splits as 4 and 4. So if I apply the zero product property, I set each factor equal to 0, so I get negative 4, and then I get positive 4. I do have to check for extraneous solutions. So right now I know that negative 4 is for sure extraneous because if I plug it in for the argument here, I would have a negative argument, and I can't have a negative argument. So for sure I know that negative 4 is out. Let's plug in positive 4. So if I have log base 7 of 3 times 4 to the third plus 4 minus log base 7 of 4, that's equal to 2. So I have log base 7, 4 to the third is 64, times 3 is 192, and I'm going to add 4 to that, minus log base 7 of 4 is equal to 2. So I have log base 7 of 196 minus log base 7 of 4, and that's equal to 2. So I'm going to use the quotient rule. If you're subtracting, you can divide these. So 196 divided by 4 is 49. So log base 7 of 49 is equal to 2. So 7 to what power gives you 49? And the answer is 2. So the only solution here is x equals 4.